National Electrical Code Section 410.30, C 1.2. C addresses the requirements for attachment plugs and receptacles for luminaires with cords and plugs. However, there are exceptions to this rule. Exception number 1 states that the luminaire is a cord-connected, permanently installed appliance such as a ceiling fan or pendant light, then an attachment plug and receptacle is not required. Exception number 2 states that if the luminaire has a cord with a length not exceeding 15 meters, which is approximately 49 feet, is permanently connected to rigid conduit or intermediate metal conduit, and is supported by a fixed permanent structural member, then an attachment plug and receptacle is not required. In a scenario where a high-intensity discharge fixture, known as an HID fixture, is hung from a rigid conduit and a hook, and the cord goes directly into a full square box with a cord connected without an attachment plug, the question of whether a plug is needed depends on whether the installation meets the conditions of exception number 2. Firstly, the cord length must not exceed 49 feet. Secondly, the cord must be permanently connected to the rigid conduit. Thirdly, the fixture must be supported by a fixed permanent structure, which in this case is the conduit and hook. If all of these conditions are met, then an attachment plug and receptacle are not required. It is important to note that the National Electrical Code requires that the cord connector in the 4 square box be of a type listed for the purpose of connecting a flexible cord to a luminaire. This means that the cord connector must be specifically designed and approved for use in this type of application. The use of an unlisted or inappropriate cord connector could create a safety hazard. When determining whether a high-intensity discharge fixture requires an attachment plug and receptacle, it is essential to carefully review the specific requirements of National Electrical Code Section 410.30, C 1.2, C and its exceptions. Consider the length of the cord, the type of conduit used, and the method of support. If all of the conditions of exception number 2 are met, then an attachment plug and receptacle are not required. The cord connector in the 4 square box must be of a type listed for the purpose of connecting a flexible cord to a luminaire. Failure to comply with these requirements could result in a code violation and a potential safety hazard. It is recommended to consult with a qualified electrical inspector or engineer to ensure that the installation meets all applicable requirements. Electrical codes and standards are constantly evolving, and it is important to stay up to date on the latest changes. National Electrical Code Section 410.30 covers the methods for providing support for luminaires, also known as lighting fixtures. Subsection C addresses cord connection. Within subsection C, paragraph 1 provides general requirements, and subparagraph 2 provides specific requirements for luminaires suspended directly or indirectly from the outlet box. In the specific case outlined, which involves a high-intensity discharge fixture suspended from a rigid conduit and hook and connected to a full square box via a cord without an attachment plug, the applicability of exception number 2 of 410.30, C 1.2, C becomes crucial. This exception allows for the omission of an attachment plug and receptacle under specific circumstances. The conditions that must be met are threefold. Firstly, the cord length cannot exceed 49 feet. Secondly, the cord must be permanently connected to rigid conduit or intermediate metal conduit. And thirdly, the luminaire must be supported by a fixed permanent structural member. In this scenario, the rigid conduit and hook combination is acting as the fixed permanent structural member. Assuming the cord length is within the 49-foot limit and is indeed permanently connected to the rigid conduit, the exception applies, and an attachment plug and receptacle are not mandated. It is paramount to emphasize the necessity of using a listed cord connector within the 4 square box. This connector must be specifically designed and listed for the purpose of connecting flexible cord to a luminaire. Using an unlisted connector violates the National Electrical Code and introduces a potential safety hazard. The purpose of this requirement is to ensure a secure and reliable electrical connection between the flexible cord and the fixed wiring system. Listed cord connectors undergo rigorous testing to verify their suitability for this application, including their ability to withstand mechanical stress, temperature variations, and electrical current. Installing an unlisted connector could lead to loose connections, overheating, and even electrical fires. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is not law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Compliance with the NEC is essential for ensuring the safety of electrical installations and preventing electrical hazards. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for various types of electrical systems and equipment, including lighting fixtures, appliances, and industrial machinery. The NEC also includes provisions for special occupancies such as healthcare facilities, hazardous locations, and swimming pools. The NEC is a complex document, and it is important to consult with a qualified electrical professional to ensure compliance with its requirements. Electrical codes can vary depending on the jurisdiction, so it is important to check with the local authority having jurisdiction or OJ for specific requirements in a particular area. Staying up to date on the latest changes to the NEC is also essential for electrical professionals. The NEC is revised every 3 years to reflect new technologies, industry best practices, and lessons learned from past electrical incidents. High-intensity discharge lighting fixtures are a type of electric lamp that produces light by means of an electric arc through a gaseous mixture. These lamps are commonly used in applications where high light output and energy efficiency are required, such as street lighting, parking lots, and industrial facilities. High-intensity discharge lamps come in a variety of types, including metal halide, high-pressure sodium, and mercury vapor lamps. Each type has its own unique characteristics such as color rendering index, luminous efficacy, and lifespan. Metal halide lamps offer good color rendering and are commonly used in commercial and industrial applications. High-pressure sodium lamps are highly efficient and are often used in street lighting. Mercury vapor lamps are less efficient than other high-intensity discharge lamps and are being phased out in many areas due to environmental concerns. When installing high-intensity discharge lighting fixtures, it is important to follow all applicable codes and standards, including the NEC. Proper wiring, grounding, and overcurrent protection are essential for ensuring the safe and reliable operation of these lamps. It is also important to select the appropriate type of lamp for the application and to consider factors such as color rendering, light output, and energy efficiency. The selection of the cord connector is also critical for ensuring a safe and reliable electrical connection. The cord connector must be listed for use with flexible cord and must be properly sized for the cord being used. The connector must also be installed in accordance with the manufacturer's instructions. Improper installation of the cord connector can lead to loose connections, overheating, and electrical fires. The requirement for the cord connector to be listed for the purpose of connecting a flexible cord to a luminaire ensures that the connector has been tested and certified to meet specific safety standards. These standards address factors such as the connector's ability to withstand mechanical stress, temperature variations, and electrical current. Listed cord connectors are typically marked with the listing agency's symbol, such as UL or ETL, indicating that they have been evaluated and found to comply with the applicable standards. Using a listed cord connector provides assurance that the electrical connection is safe and reliable. In addition to using a listed cord connector, it is also important to ensure that the connector is properly installed. The installation instructions provided by the manufacturer should be followed carefully. The cord should be securely clamped or fastened to the connector to prevent strain on the electrical connections. The connector should also be properly tightened to ensure a good electrical contact. Over-tightening the connector can damage the cord or the connector itself. The National Electrical Code is not intended to be a design manual. It is intended to provide minimum safety requirements for electrical installations. The design of an electrical system should be performed by a qualified electrical engineer or designer. The design should take into account factors such as the load requirements, the voltage drop, and the available fault current. The design should also comply with all applicable codes and standards. In addition to the NEC, there may be other codes and standards that apply to electrical installations. For example, the International Building Code, or IC, contains requirements for the installation of electrical equipment in buildings. The Americans with Disabilities Act, or ADA, contains requirements for the accessibility of electrical equipment. It is important to be aware of all applicable codes and standards when designing and installing electrical systems. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical installations. Electrical systems should be inspected periodically by a qualified electrical professional. The inspection should include a visual examination of the wiring, equipment, and connections. Any damaged or deteriorated component should be replaced promptly. Electrical equipment should also be maintained in accordance with the manufacturer's instructions. This may include cleaning, lubrication, and testing. Proper maintenance can help to prevent electrical failures and extend the life of electrical equipment. When working with electricity, it is important to take precautions to prevent electrical shock. Electrical shock can occur when a person comes into contact with a live electrical conductor. The severity of the shock depends on the voltage, the current, and the duration of the contact. Electrical shock can cause burns, muscle contractions, and even death. To prevent electrical shock, it is important to de-energize the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse. It is also important to use insulated tools and equipment. Rubber gloves and safety glasses should be worn when working with electricity. If you are not comfortable working with electricity, it is best to call a qualified electrical professional. The information provided in this video is for general educational purposes only and should not be considered as a substitute for professional electrical advice. Always consult with a qualified electrical professional before making any electrical installations or repairs. Failure to comply with applicable codes and standards can result in serious injury or property damage. Electricity is a powerful force, and it should be treated with respect. By following safe electrical practices, you can help to prevent electrical accidents and protect yourself and others from harm.